When you get to calculus, you'll go over a calculus definition of the intermediate value theorem, but for the course that this question comes up in, the intermediate value theorem says that if the signs at the endpoints are opposite, like if one is negative and one is positive, or vice versa, one's positive and one's negative, then you're guaranteed to have a zero, because polynomials look something like this, right? Depending on what the details are of the polynomial. So polynomials are smooth as you trace with your finger. You never have to lift up your finger. There's no breaks, and eventually gradually comes to a maximum, a local maximum, and then it starts falling back down, hits local minimum. So what's being said is that if you have a polynomial on some interval where like maybe one part of the interval is a negative number and then the other part of the interval is a positive number, then no matter how you draw the polynomial, if it's a polynomial, it's got to cross at zero at least one point. Okay, so that's basically the intermediate value theorem. So all you're doing for these is you're going to plug in 1 in for x, see what you get. So 3 plus 3 makes 6. 6 minus 4 makes 2. 2 minus 1 makes 1. And then plug in 3 in for x and see if the signs are opposite. So it's 27 times 3. So it's 81 there. And then 81 plus something else big. So this is going to be 12 minus 1. That's 13. This is definitely going to be positive. I'm not going to figure out exactly what number it is, but I know it's going to be positive. The intermediate value theorem does not guarantee a zero there, because the endpoints are both positive. They have to be opposite signs. So if I do the same thing for the next function, if I plug in 1, I'm going to have 2 minus 4 makes negative 2. Negative 2 minus 4 makes negative 6. And if I plug in 3, then 3 cubed is 27. 27 times 2 is 54. 54 minus 36. I'm getting close here. 54 minus 36 is 18. And then we've got 18 minus 12. I might have messed something up with my math, but I'm pretty sure it's going to be positive. You plug in 1, you get out a negative number. You plug in 3, you get out a positive number. Between these two x coordinates, we know that there's at least going to be a zero somewhere. This one has opposite signs in the endpoint, so this one is the one they're looking for. There's a zero guaranteed by the intermediate value theorem.